Okay, today we're going to finish our discussion on types of solutions. If you recall previously, we talked about cell membranes, osmosis, the movement of water in and out of cells across the cell membrane. And we kind of touched on the three different types of solutions, but we didn't go into it too much. The first one we're going to talk about is called hypertonic. Now, in a hypertonic solution, what we have is a solution that is more concentrated outside the cell than it is inside the cell. So we have the outer part of the cell and the inside of the cell. And that's separated by the plasma membrane here in the center. Okay? So what we're going to start with is how much water do we have on both sides? So we have water. I'm, making my water molecules very complex. You'd never know they were water. And then we need some other molecule. I'm going to call it sugar, okay? And my sugar are going to be terribly complex. I'm going to make it a little S. So we have lots and lots of sugar outside the cell. This is a concentrated solution. So we have a lot of molecules of sugar compared to water. And on the inside, we have very little solute. So we only have a couple. Compared to the outside, put some more in there. So we see how concentrated that is. Now, when you have a very, very, very concentrated solution, the solute, sugar, to solvent ratio, the water, is higher outside the cell. So you have a lot more solute compared to the solvent. And that will affect your cells by changing the direction that the water goes out of from the cell. When you have this much solute outside the cell, what happens is that water is going to start flowing outside of the cell to even out the concentration of water. Remember, this is a random movement as the molecules bump into each other and all that, so a little bit's going to come back in. But mostly, we're going to have water flowing outside the cell. And what that will lead to is a shriveled up cell. So the cell ends up losing water. So we lose water. It shrinks. And this can actually be really bad. So this is why, can't get shrinks on there. This is why it's really bad for you to, have too much sugar or very salty water. Everybody's heard that if you're stranded in the ocean, you shouldn't drink the water. Well, that's because when you have a very concentrated solution, you have all this water that starts flowing out of your cells, and that would dehydrate you. Now, the other type of solution that the next type of solution that we're going to talk about is called hypotonic. And again, this is going to be the outside of the cell, and this is going to be the inside of the cell. And in a hypotonic solution, what we have is a more concentrated solution inside the cell than outside. So again, we have our water. We have our water. And then we're going to have, again, some solute. We're going to call it sugar again. And we're going to have very little solute outside the cell. But we're going to have a lot inside the cell. Very concentrated solution inside the cell. So what happens, because we have so much solute inside the cell, very concentrated, what's going to happen is that water is now going to start flowing into the cells. To even out this concentration, water is going to flow from the area of high concentration to an area of low, because it's less concentrated. A little bit will make it back through, but most of it's going to go rushing into the cell. Now, hopefully you can guess what would happen is that we would have, this would also cause a problem. The cell is going to expand because you have so much water coming into the cell's actually going to get bigger. Now, if you were already dehydrated, that water flowing back into your cell would help to rehydrate you. But if you were already perfectly hydrated, so much fluid flowing back into your cells could actually cause your cell to rupture or burst. So that's why you're not supposed to drink, distilled water or pure water when you don't have like a medical need to. So if you're not severely dehydrated, you drink tap water, bottled water, that is not pure water. It has other minerals and stuff, and so that doesn't cause it doesn't cause water to go rushing into your cells. But if you were very dehydrated and you've been drinking salt water, and you're very, very dehydrated, then any kind of water would actually be hypotonic to your cells, and that would cause water to flow back into your cells and rehydrate you. Now, the last type of solution we're going to talk about is called isotonic. So we're looking at a solution that the concentration of the water outside of the cell and the water to, solute to solvent ratio, the concentration is the same outside and inside the cell. So this is, what normally happens for us when if we have a regular concentration, we're not dehydrated, we're not overly hydrated. This is normal. So you can see we have 5 molecules of sugar outside the cell and 5 inside. So this is equal. It's not common for a solution to be exactly equal, but even enough that the movement of water into the cell and out of the cell is roughly equal. So it's not going to cause your cells to actually change in size. It causes your cells to stay roughly the same. So there's no overall change in the size of the cell. And this is what we're normally looking for. This is when we're at homeostasis and what we're taking in equals what's going out. And this is normal for us if we're not overly hydrated or, overly dehydrated. So there'll be a little bit of movement of water inside and out, or out of and into the cell, but roughly equal.